All right, now let's talk about inequalities. So the first section, let's talk about solving the quadratic inequality using a number line. So as always, pause the video for the examples and try them on your own to get the most out of it. But let's try this one. So the first thing I'm going to do is move this minus 3 over. So become 2x squared minus 7x plus 3 greater than 0. And then I'm going to factor this down. So to factor it, I'm just going to use guess and check. So two brackets that will have 2x and an x, because that's how we can get an x squared, or 2x squared. And then what I'm going to do is try numbers that multiply together to get 7. Or no, this should be plus 3. Multiply to get plus 3 and then add to minus 7. So let's try. I think it should be here. So plus 1, or no, minus 1 and then minus 3. Because minus 3 times 2x will give us minus 6x, and then minus 1 times x will give us minus x, which add up together to get the middle term, minus 7x. So now, that's our factored form. We can, I'm just going to make another page, make a number line, and set each of these equal to 0. So we would get 2x minus 1. When you set this equal to 0, you will get 1 over 2. And then the other bracket will be 3. Because when you put x is 1/2 or 3, or just set those equal to 0, you'll get 1/2 and 3. So then you can put 1/2 and 3. So 1/2 and then 3. And then now what you're going to do is test where the inequality is true. Like what numbers for x around those like endpoints is the thing equal to greater than minus 3. So if we plug in, for example, 0 for x, we will get 0 is greater than minus 3, which is true. And 0 is over here. So I'm just going to make it blue. So that is true. If we plug in something around this interval, 1/2 to 3, let's say we plug in 1, we will get 2 times 1, 2, minus 7. So basically minus 5 is greater than minus 5 greater than minus 3, which is false. So that is not part of our solution. And then if we do something greater than 3, so if we plug in something like 4, it will continue to be true. We'll get 4 is greater than minus 3. So this is also part of our solution. So the way we would write this is x such that x is greater than 3, comma, x is less than 1 over 2. Perfect. Let's try this example. 1/2 x squared minus 8. So in this one, I'm gonna factor out the x squared, and then this will give me x squared minus 16 is less than 0, and then that's a difference of squares, so it's going to be x plus 4, x minus 4 less than 0, and then I'm just going to make another page and another number line. So the critical points here would be 4 and negative 4. And then again, I'm just going to check around the intervals. So plug in numbers that are in between minus 4 to 4. So let's say if we plug in 0 is 0, or if we plug in 0, we'll have minus 8 is less than 0, which is true. So this is part of our solution. And you'll realize that if you do this correctly, it'll either be the two end ones, or it will be the middle one. But you can always plug and play to make sure that it's like what you're getting is right. if you plug in stuff to the left or the right, so if you plug in something like -5 or +5, you'll realize that the equation will be false. And again, we just plug it into the original equation for x. So as a result, our solution here will just be when x is in between 4 and -4. Good. Let's give this one a try. And this one I'm just going to change it to 2x squared minus 6x greater than 4x. So this one, 2x squared minus 4x, I'm just going to move it over, minus 6 is greater than or equal to 0. And from here, we're going to factor. So there, all the terms are divisible by 2. And then this is easy to factor down, just using guess and check again. So x minus 3, and then x plus 1, because then you do the outermost times the outermost, you'll get 1x. You do innermost times the innermost, you'll get minus 3x. If you add them together and you get the middle term, you'll realize that it's correct. And then let's make a number line. And this tells us that the critical points are when x is equal to 3 and at -1. So I'm going to put -1 and 3, and then I'm going to test around it. When I put in something like -2 in for x, then I will get 2 is greater than or equal to -8, which is true. So that is part of the solution. If I plug in something in between, like if I plug in, say, 0, then I'll have -6, because this is all 0, is greater than or equal to 0, which is not true because -6 is less than, so that's not part of the solution. And then if I plug in something like 4, something to the right of 3, I will get 26 is greater than or equal to 16, which is true. So that is also part of the solution. So for this one, the answer would be when x is less than or equal to -1, comma, x is greater than or equal to 3.